Hello everybody. There are 4 areas of arithmetic where students often have difficulty. Those areas are negative numbers, fractions, exponents, and irrational numbers. The first 3 of these topics are normally covered in grammar school, and so, as we get older, we are often embarrassed by our inability to master these topics. Sometimes we allow the memories of our past difficulties to get the best of us until we approach these topics with an excessive dread, which is really unfounded. On this video, we're going to combine 2 of these problem areas. We're going to discuss working with negative fractions. Well, I think this is a good example of what I mean by excessive dread. Although I don't suppose I'm helping anything by making this video number 13 in our series. Take my word for it though, you can succeed in mastering this topic. Videos number 3 and 4 in our series talked about working with negative numbers, and video number 5 is a quiz on those skills. You may want to review these videos if your negative number skills feel a little shaky. Videos 10, 11, and 12 are about working with fractions. It may help you to review those videos as well. There are rules for the arithmetic operations of addition, subtraction, multiplication, and division when negative numbers are involved. And there are rules for addition, subtraction, multiplication, and division when fractions are involved. When we deal with negative fractions, we will have to use both sets of rules. The good news is that we've already covered all of those rules. We just need to practice using them. That is what we're going to do with this video. The first thing I want to do is refresh in your mind a concept I discussed in the earlier videos on negative numbers. This concept is that every number has 2 important qualities. The first is magnitude, and the second is direction. When we first learned numbers as toddlers, and then in our first few years of schooling, we only learned about the magnitude of a number. We started our math journey with counting numbers, which are either larger or smaller than other counting numbers. That relative size is the magnitude of a number. We didn't learn about direction in those first few years. There was no need. The counting numbers are all positive, and therefore all have the same direction. But the counting numbers are an incomplete picture of the realm of numbers. There also exists negative numbers. Negative numbers require us to consider a direction as well as a magnitude. Recall that we can express all real numbers as representing points on a number line. Normally, the number line is centered around 0. Let's put the positive and negative integers on the number line as well. By convention, the numbers to the right of 0 are positive numbers, and as they increase in magnitude, that is the positive direction. To the left of 0 are the negative numbers, and as they increase in magnitude, that is the negative direction. On the number line, the magnitude of a number is represented by the distance or length that the number is from 0. For this discussion, I use the term distance and length interchangeably. Length is always expressed as a positive number, so you can either think of magnitude as having no direction or always having the same positive direction. The only important quality of magnitude is length. For instance, the numbers 5 and negative 5 are numbers with the same magnitude. They are both 5 units long, since they are both 5 units from 0. Negative 4 is twice the magnitude of 2, since negative 4 is twice the distance from 0. We have a mathematical expression called the absolute value of a number. The notation we use for the absolute value of a number is 2 straight vertical lines as shown. When we take the absolute value of a number, we are considering only the magnitude of the number, that is, only its distance from 0. Therefore, the absolute value of negative 5 equals 5. The absolute value is always a positive number. As you go to the right on the number line, the numbers become progressively greater. Therefore, the number 5 is greater than the number 2, since 5 exists to the right of 2 on the number line. Conversely, 2 is less than 5, since it is to the left of 5 on the number line. By extension, 2 is greater than negative 4, since 2 is to the right of negative 4 on the number line. Conversely, negative 4 is said to be less than 2. Whether a number is greater than or less than another number is dependent on both the direction and magnitude of the number. All positive numbers are greater than all negative numbers because they all exist to the right of 0 on the number line. But as we saw when we compared negative 4 and 2, a negative number can have a greater magnitude than a positive number.
Excuse me.
Is this the fraction fairy again?
Yes. I was under the apparently mistaken impression that this lesson was going to be about fractions.
Well, yes.
And yet I haven't heard any discussion of fractions. Do you really think I have all day to listen to you prattle on about magnitudes and directions?
Okay, I'll start talking about how fractions tie into all of this.
See that you do so immediately.
Yes, Your Highness.
Very well. Good day.
So on that note, let's move on to fractions. We normally just show the integers on a number line, but each number has a place somewhere on the line. Let's expand the segment of the number line around 0 to take a closer look. We can put in some of the more common fractions. Similar to dividing a pizza into several equal slices, we can divide the interval on the number line between 0 and 1 into equal segments. For instance, if I divide that interval into 4 equal segments, then the length of the first segment represents 1/4, the second segment is 2/4 or equivalently 1/2, the third segment is 3/4. I can divide the interval between 0 and 1 into 3 equal parts or 5 equal parts, and therefore fill in the appropriate fractions to represent those segments. Of course, I'm not restricted to the interval between 0 and 1. Any fraction I can write has a place on the number line. I can represent 3/2 or 5/4 or 5/3. For every positive fraction, there is a negative fraction of the same magnitude but opposite direction. We can add some of those fractions to our number line. Let me explain one more thing about negative fractions. All negative fractions are annotated with a minus sign, but the minus sign can be in front of the fraction, or in the numerator, or in the denominator. It doesn't matter. These three notations for -3/5 are all equivalent. Let's talk first about addition involving negative fractions. Remember that we don't have new rules. We just have to combine both the rules for adding negative numbers and the rules for adding fractions. Let's review those rules. For addition involving fractions, we have to find the least common denominator between the two fractions and convert the fractions into equivalent fractions with that common denominator. Then we add the numerators and keep the common denominator. For addition involving negative numbers, if the fractions have the same sign or direction, then add the magnitudes and use that common sign or direction. If the fractions have opposite signs or directions, then subtract the magnitudes and take the sign of the fraction with the largest magnitude. Notice that I will often use the term sign and direction interchangeably, since one implies the other. Let's try a couple of examples. What is -2/3 plus -1/4? First, let's express both of the fractions as equivalent fractions with a common denominator. The least common denominator is 12. The fractions are equivalently written as -8/12 plus -3/12. Now we notice that both fractions are negative, so we add the magnitudes of the fractions together. This gives us a value of 11/12. Since the common sign is negative, the answer is -11/12. What is -3/4 plus 1/3? Again, we start by converting both fractions to equivalent fractions with a common denominator of 12. We get -9/12 plus 4/12. The fractions are opposite signs, so we subtract the magnitudes and take the sign of the fraction with the largest magnitude. 9 minus 4 is 5/12. The fraction with the largest magnitude is negative, so the final answer is negative 5 over 12. Now let's talk a little bit about subtraction. Recall that we can change any subtraction problem into an equivalent addition problem. So we do this and then use the rules for addition. We change a subtraction problem to an addition problem by converting the fraction we are subtracting to a fraction of the same magnitude but in the opposite direction. Let's try to solve the following problem. What is negative 5/6 minus 1/4? Don't get confused here. As the problem is currently written, 1/4 is a positive number. The minus sign indicates the operation of subtraction and does not indicate negative 1/4. However, to convert this problem to an addition problem, we would change the direction of 1/4 from a positive number to a negative number. Now our subtraction problem has become an addition problem, that is, negative 5/6 plus negative 1/4. The next step is to again convert both fractions to equal fractions with a common denominator of 12. Now our problem is negative 10 over 12 plus negative 3 over 12. Both fractions are negative. We add the magnitudes and the result is negative 13 over 12. This is an improper fraction. If we choose, we can convert this to a mixed fraction of negative 1 and 1/12. Let's try one more subtraction problem. What is negative 1/2 minus negative 1/4? First, convert this to an addition problem by changing the direction of negative 1/4 to positive 1/4. Our problem has evolved to negative 1/2 plus 1/4. The denominators of these fractions are 2 and 4, respectively. The least common denominator is 4. Convert negative 1/2 to negative 2 over 4. The second fraction already has 4 as the denominator, and so no conversion is necessary. Our problem is now negative 2 over 4 plus 1 over 4. The signs of the fraction are opposite, so subtract the magnitudes. The resultant magnitude is 1 over 4. The direction is negative, since negative 2 over 4 has the larger magnitude. Multiplying and dividing negative fractions is a relatively easy process. The rule for multiplication of fractions is that we multiply the two numerators together and multiply the two denominators together. The rule for dividing fractions is that we flip the second fraction and multiply. Remember that you can cancel out factors that are common to the numerator and denominator to make the multiplication easier. The rule for multiplication and division of negative fractions is that if both fractions have the same sign, the answer is positive. If the signs are opposite, the answer is negative. Let's do a multiplication problem. What is negative 2/3 times 1/4? First, I can cancel a 2 from the numerator and denominator. I am left with a 1 in the numerator, and the denominator is 3 times 2, which is 6. The fractions have opposite signs, so the answer is negative 1/6. Let's try a division problem. What is negative 4 over 7 divided by negative 4 over 5? First, flip the second fraction, the divisor. Now our problem is negative 4 over 7 times negative 5 over 4. We can cancel a 4 from both the numerator and denominator. We are left with 5 over 7. Since both of the fractions we multiplied are negative, the final answer is positive 5 over 7. That wasn't so bad, was it? Good. Working with fractions has some advantages. Fractions are used extensively in construction and manufacturing as a result. But addition and subtraction of fractions can be difficult and time-consuming. In some areas where fractional addition and subtraction is particularly important, like finance for instance, we use decimals in lieu of fractions almost exclusively. This is what we will be studying in the next video.
Excuse me, did I hear you call fractions difficult and time-consuming?
Well, yes, particularly for addition and subtraction.
Explain yourself, young man.
Thank you for the young man comment, by the way, Your Highness. Here's what I mean. Suppose I have a problem like -9 over 25 minus 13 over 35. That would take a while to solve.
Of course not. The answer is -128 over 175. You can't see that by simple inspection?
Well, no, actually I can't. May I say, Your Highness, that most of us are not blessed with your intellect and, may I add, beauty.
Yes, you may say intellect and add beauty.
Well then, I really have a responsibility to my students to teach them about decimals. It is, after all, a legitimate area of arithmetic.
It is a newfangled passing fancy, if you ask me. Why, decimals haven't even been in use for a single millennium, and I doubt they'll be around for another.
Be that as it may, decimals are around now. My students need to learn about them.
Continue on this scurrilous and utterly frivolous course of action, if you must. Just be very careful on your comments about my branch of arithmetic.
Scurrilous?
You heard me. Goodbye.
Well, there you have it. You can see that, like fractions themselves, the fraction fairy can sometimes be a challenge to work with. On the next video, I will attempt to discuss decimals in as non-scurrilous a manner as possible. In the meantime, have a good day.
We hope to see you at Veterans Upward Bound very soon and recommend a friend.